Well, thank you, Sir Peter, and thank you to the Institute of Physics for the award. It's a great honour, genuinely, to receive an award like that from my peers. I really do appreciate it. And as Sir Peter said, I believe that we are entering, or we certainly have the possibility of entering a new golden age of physics. The statistics speak for themselves, the increase in interest in physics across all areas of the public, but also the increase in applications to university, I think, is something that many of us thought we'd never see. And I suppose one of the reasons for that is the great success that we've had in research over the last couple of years. I'm thinking particularly of the Nobel Prizes in physics for the discovery of graphene. And, of course, as Sir Peter mentioned, the Large Hadron Collider. Now, I know that many of you here actually work on the LHC, but I also know there are a lot of people watching this on the web, apparently, I was told today. So I was asked to give just a brief I suppose an overview of the tremendous scientific achievement that the LHC and CERN and, of course, Peter Higgs's theoretical achievement back in the 1960s, what an achievement that is. I mean, if you think about it, back in 1964, I think the first papers were published, Peter Higgs and colleagues predicted that we live in a condensate. So less than a billionth of a second after the universe began, something happened, a phase transition, probably, which caused the Higgs field, Higgs particles, if you like, to condense out into the vacuum. The figures are remarkable. I had to check this several times. I've written it down here. The number is that if you asked a naive question, how much energy is contained in that field, the binding energy of this condensate, then per meter cubed, in every meter cubed volume of space, 10 to the 37 joules of binding energy in that condensate. If you do the simple sums, that's more than the energy output of the sun in 1,000 years per meter cubed of space, which should, given our current understanding, blow the universe to bits in a fraction of a second. It obviously doesn't. We don't know the answer to the question why. But if you think about it, it's a very bizarre prediction. It's strange. It's I think one of the best examples of Wigner's famous essay, The Unreasonable Effectiveness of Mathematics in the Physical Sciences. This is a mathematical prediction made in the 1960s, before the Standard Model was there, before we had a mature theory of the way that the strong force, the weak force, the electromagnetic force stick together. And yet that prediction has persisted all the way through to this day, to the point where over 80 countries from around the world got together and built, in many ways, the most sophisticated machine, the most sophisticated scientific experiment ever built, in many ways the most sophisticated machine that was ever built, operated it at the moment probably beyond design expectations, and discovered that that prediction of nearly 50 years ago now was true. It's a tremendous scientific achievement. It's a very strange prediction. It's a very strange discovery that's going to take many, many years to understand and unravel. I've heard it described as a door that's been opened to a new world of physics, and I think that surely is correct. So a tremendous amount of work to do at CERN. But also, it was a tremendous cultural triumph. It had an enormous cultural impact. And I've written down some of the headlines here. One of my favourites was The Sun, which said, "Subatomic smitten." Well, that was the those of you that know, subatomic smitten. It also underneath said, it reported in detail what Peter Higgs did on the day. And this is The Sun, this is headlines in the biggest selling national newspaper in the UK. It said, Peter celebrated by drinking a can of London Pride. And it quoted... And it quoted him. He only gave one quote to them. He said, "It's very nice to be right sometimes." That was his... The Daily Mail even said it was a momentous day for science, although that followed their headline on the day we turned the Large Hadron Collider on for the first time, which was, "Are we going to die next Wednesday?" And I thought it was amusing. I've got the article here from the Mail. I thought you'd be amused to see. There's actually a serious point to this, actually, which I'll make afterwards. But first, you can laugh at this journalism. They said that there were two potential problems with the LHC, the problems it might cause for humanity. And this is word for word. They said, for maybe a month, this is the least problematic scenario. For maybe a month, there will be no sign that life is about to come to an abrupt and nasty end for all living things on Earth. Earthquakes will start unexpectedly, alerting geologists that something terrible is amiss. After a few days, these seismic disturbances will reach catastrophic proportions. Cities will be leveled, the oceans will rise and wash in a series of mega tsunamis that will attack the world's coast, killing millions. This is the LHC. The fact that the earthquakes are striking at random will be proof that something devastating is afoot. So a bit of science there. The end will come in a disaster on a biblical scale. The earth will start to crack up, molten lava will wash over the land, and the seas will start to boil. Mega hurricanes will level buildings and forests the world over. Mountains will crumble, the earth's crust will continue to disintegrate. The fabric of the planet itself will start to disappear, and from space, our blue and white home will vanish down a plug hole in a flash of light. At least in this scenario, we will have a little time to come to terms with the end. However, the second scenario is even worse. There'll be no warming at all. In an instant, in about 1/20th of a second, I don't know where this calculation comes from, in about 1/20th of a second, the entire Earth will vanish. Less than 2 seconds later, the moon will follow suit. I see what it is. It's probably the light travel time across the... I've just realised that, and I don't... Clever. 8 minutes later, the sun will be ripped apart, followed by the rest of the planets in the solar system and onwards, a wave of destruction caused by a rent in the fabric of space itself, spreading out from our world at the speed of light. Any extraterrestrials will eventually die too in due course. But then it goes on. The answer to what could possibly cause this is the Large Hadron Collider to be turned on next Wednesday. But it says, then at the end, it says, I put this to scientists at CERN, and my proposal was released, this is the exact words, elicited only raised eyebrows and shrugs of derision. There we are. Anyway. So, my point is, though, does this really matter? I mean, you could look at this and say, well, at least science, particle physics was on the front page. But I think it does matter. You see, the point is that we live in a society, as the great physicist and communicator Carl Sagan always emphasized, a society that is entirely based on science. It is based on technology and engineering. All the great important decisions that our democracy will be forced to take in the next decades and onwards into the 21st century are based on science. They're based on the scientific method. They're based on an understanding of what reason and reaching conclusions based on evidence is. And if the presentation of science is a Frankenstein presentation of science, a misrepresentation of what we do, a complete mis-selling of the wonder of exploration, then we have a problem in our democracies. And it's the same problem that we have if we don't have an educated population, a population that is educated in STEM subjects, as Sir Peter emphasized. So for a democracy, a modern scientific democracy, to function correctly, then you need as many citizens as possible to at least have an understanding of the scientific method, if not the facts. You don't need to know the mass of the Higgs boson, but you need to know how we go about answering questions such as, how did the fundamental particles acquire mass in the universe? It's the scientific method that matters. So it's not acceptable to do that. It's not acceptable to claim, and I'm going to quote here, and I'll tell you who wrote this later, it's not acceptable to claim that homeopathic care is enormously valued by thousands of people, and it ought to be available where a doctor and patient believe that a homeopathic treatment may be a benefit to the patient. Jeremy Hunt said that, the health secretary. That's a statement to evidence-based medicine, what Nigel Lawson is to polar ice caps. And even the Telegraph, let's give it some credit, wrote of that statement that homeopathic hospitals are, and I quote, white elephants for middle-class hypochondriac hippies. Even the Telegraph. So it's not accuracy. It's not acceptable to attack the claims of science. I'm thinking particularly about climate change here, because you don't like the economic impact of the problem. It's not acceptable to not understand what the difference is between data and modelling and political statements about what you do about the consequences of that data and modelling. I'm always reminded of my friend Dara O'Brien, who talks in wonderful terms about these ideas. He says that there's no such thing as alternative medicine. Right? There's medicine, which has been shown to work, and there's potpourri. Right? There's a reason why we don't have aircraft that run on, well, homeopathic aircraft that run on the memory of petrol. environmentally friendly as they are. There's a reason we don't use Reiki to fix aero engines. Faith-based aviation doesn't work. You get a lot of people sat on the ground at the end of the runway watching everybody else take off. And that is... I think that's probably a metaphor for our economy at the moment. I noticed the Royal Academy of Engineering report actually earlier, I think it was earlier this week or maybe last week, which made quite salutary reading for the future of our economy if we don't do something, if we don't invest in STEM subjects, if we don't change this attitude that is prevalent in many parts of society, that science is just one, or scientists and engineers are just one set of interest groups amongst a wider population. The Royal Academy of Engineering said that we need, or found that we need 100,000 STEM graduates per year into the economy in order to stand still. 1 million, of order 1 million by 2020, and around 500,000 technicians. Now, those are big numbers. Currently, we graduate around 90,000 STEM graduates per year, but that includes foreign students, and around 25% of those don't remain in the STEM industries. So you can see there's a shortfall into the economy to stand still of something like, what, maybe 25, 30,000 STEM graduates per year. So my personal view is that, as Sir Peter said, we've turned the corner in some sense. We, as a community, have, in a sense, done our job. Right? We've convinced young people that physics, that science and engineering are things that they should be interested in and are worthwhile doing. My challenge to government now is, what are you going to do about that? Because we're finding it difficult to educate them all. I know at Manchester we have entry requirements now in physics, I think, of A star, A star, A, which is to be applauded. But in a sense, it seems to me it's a market failure, because there are more people that want to come and do physics at Manchester than we can take, because we don't have the infrastructure, we don't have the lab space, we don't have the lecture theatres and the staff to teach those people that are vital for our economy. And don't say we can't afford it. There was another interesting report that came out last week, I think, the OECD. It was looking at the impact of tertiary education on economies. It's a very detailed and careful report. It found that the net return on public investment in the UK on a person who goes through tertiary education, so not STEM necessarily, but just tertiary education, is around $70,000 over their lifetime. So after you subtract out all the loss of tax income while they're at university or while they're in tertiary education, and then all the cost of their education, you still find that $70,000 on the average comes into the economy over the lifetime. You multiply that by 1 million STEM graduates, there's $70 billion for those extra 1 million graduates we want over the next, 10 years. There are other social contributors. It's a fascinating report. Life expectancy is 8 years longer for males who go through tertiary education than males that don't. 27% more tertiary educated people vote than non-tertiary educated people. So you increase the participation in the democracy by an incalculable amount. Over half the GDP growth in all OECD countries over the past decade came from tertiary education, tertiary educated people. Half of GDP growth. That sector of the UK economy grew last year, even though we're in recession. So where would this investment come from? I'm talking about the investment to build our capacity to educate more STEM graduates. Well, there's a very interesting campaign that you're going to hear a lot more of. Imran Khan, who's set over there, is going to run the campaign, also James Dyson. The idea is to look at the sale of the 4G spectrum, which is going to raise at least $1 billion, $1.5 billion, possibly more than that. I know Ed Bowles recently suggested that should go into a stamp duty holiday. What the suggestion of this campaign is that money should go into science infrastructure. It's Maxwell's money, I would say, actually, the 4G spectrum. That wouldn't transform the science budget. I noticed that the Lib Dem pledge to increase the science budget year on year by 3% a year is very important. That's what we should be trying to get all parties to commit to. 3% increases year on year in the science budget as a whole. But that infrastructure money from the sale of the 4G spectrum could at least provide us with the capacity to educate all these STEM graduates that we need. And I just want to finish by saying this isn't new, right? The need of an economy for STEM graduates, for physics graduates, and all the way through engineering, mathematics, and the physical sciences isn't new. I was at the Royal Institution a few weeks ago, and I was shown the prospectus from the Royal Institution, the founding document. Essentially, it's the document that they were giving to potential donors to explain why an institution which promoted science and engineering was necessary. In 1799, it was primarily written by Joseph Banks. And I found this paragraph in it, which is remarkably modern. All you have to do in it is, you've got to remember at the time, it was the rich that held the power in Britain. So there's a word in here about the rich. It means really the politically powerful, the influential opinion formers. But it says this, right at the end of the prospectus: "But in estimating the probable usefulness of this institution, we must not forget the public advantages that will be derived from the general diffusion of a spirit of experimental investigation and improvement among the higher ranks of society. When the rich shall take pleasure in contemplating and encouraging such mechanical improvements as are really useful, good taste, with its inseparable companion, good morals, will revive, rational economy will become fashionable, industry and ingenuity will be honoured and rewarded, and the pursuits of all the various classes of society will then tend to promote the public prosperity." I mean, I think that, with a slight modification from the rich to the influential and powerful, should be presented to David Cameron and every future Prime Minister, because it's as true today as it is to now. And remember, at the time, in 1799, Britain was in danger of being extinguished. We're in a crisis greater than the one we are now. We could have ceased to be as a nation if we hadn't won in 1812. The economy was in a mess, and these people felt that engineering and science was the way to secure the future of the then empire and the economy in general. And I think that was echoed by, I want to finish with a quote that I really think is very powerful. It was given by Humphrey Davy not long after that. When asked, why do you want to do this? Why do you want to continue to explore? We're talking about the early part of the 19th century now. The common refrain, surely we know enough. We don't need to build an LHC. We don't need to go and do medical research. We know enough now. Well, it's nonsense. Davy knew it. And he said, in response to that charge, nothing is more fatal to the progress of the human mind than to presume that our views of science are ultimate, that our triumphs are complete, that there are no mysteries in nature, and there are no new worlds to conquer. Thank you very much. I really want to thank the University of Manchester and the Royal Society for supporting me and allowing me to take a minor career break, I suppose, and make television. But most of all, I'd like to thank my colleagues here at the Institute of Physics and all my physics colleagues, because it is certainly true that without you, I have nothing to say at all next time I stand on a mountain. Thank you very much.